In this lesson, I'll give you an overview of the Android Location and Sensors chapter. In the lessons of this chapter, we'll look at some demos for implementing location and sensor-based features in your apps. So on to the overview. Mobile devices now have really incredible abilities to sense their position, motion, and environment. Mobile devices use a combination of hardware and software-based capabilities to implement these features. Not all devices have all these features, but many devices have a good number of them implemented. Let's first take a look at how you determine a device's location. There's a good page on the developer's website about this, the Locations Strategies page. In developing location-aware applications, you can utilize GPS, the Global Positioning System, and Android's network location providers to acquire the device location. GPS is the most accurate. However, it has some negatives. It only works outdoors, it consumes a lot of battery power, and sometimes doesn't return the location as quickly as users would like. An Android network location provider determines user location using cell tower and Wi-Fi signals. It works indoors and outdoors, responds faster, and uses less battery power. To obtain the user location in your application, you can use both GPS and the network location provider, or just one. Location capabilities can be combined with maps to create powerful apps that show users where they are on a map and where other places are located. The Location and Maps page gives an overview of these features and some good links to other sources you'll need to implement maps-based apps. Now let's take a look at sensors. They're listed in tables in the sensors pages of the developer's website, along with detailed information about using them. So let's take a look. On the motion sensors page, we have the accelerometer, which senses acceleration, including gravity, along the X, Y, and Z axes. Gravity senses the force of gravity along the three axes. Gyroscope senses the rate of rotation along the three axes. Linear acceleration senses acceleration excluding gravity along the axes, and rotation vector senses rotation along the three axes. The position sensors include magnetic field, which senses geomagnetic field strength along the three axes, and orientation, which senses positioning relative to the three axes. Then this was deprecated in Android 2.2. New implementations use the device's magnetic field and accelerometer sensors in combination to provide orientation data. And finally, proximity senses distance from an object. On the environment sensors page, we have sensors for ambient temperature, light, pressure, relative humidity, and temperature. That's our overview of location and sensors. Now let's move on to the lessons on creating apps to use these capabilities. In this lesson, you'll learn how to implement device sensor capabilities in your Android apps. We'll use a demo, so let's look at our demo worksheet. In the worksheet, we'll filter the demo name on sensors. We get one entry, the sensors demo in the OS primary group. So let's fire it up in the emulator. We'll click OS, then sensors. Now we don't see anything happening because the emulator doesn't have the sensors a mobile device has. So here's what I'm going to do. I'm going to open the app up in Eclipse in DDMS using my phone. So we'll open up DDMS, select my phone. I'm going to start the app, and it's collecting sensor data. I click on the capture button, and there we have it. So let me rotate this so that you can get a better view of the screen. And we see the screen with lines plotted representing sensor values. Notice that there are 6 lines. I don't know if you can make them out: blue, green, light blue, purple, red, and then there's a yellow line way down here. It's a little hard to see. And these are the X, Y, and Z axis data from the accelerometer and magnetic field sensors. Now let's open the sensors demo Java file to study the code. In the OS source folder, we'll open sensors. This code contains some graphics functions that I won't be going through in detail, and you can review our lesson on canvas graphics for more background on these functions. So let's get started. Line 50 declares our sensors activity. Line 51 declares a sensor manager variable, and this is the class that gives us access to the device's sensors. 52 declares a graph view variable based on the graph view class defined beginning in line 54. Lines 54 through 205 define the graph view class, which extends the view class and implements the sensor event listener interface. Lines 56 through 70 define a number of variables and objects we'll be using below. 72 through 84 define a class, GraphView, that's identified below in the onResume method as the method to be invoked in response to a listener set up to watch for deliveries of sensor data from the hardware. Now let's take a look at that onResume method. And here I'm skipping the graphing code that you can go through yourself and review the Canvas Graphics chapter for more background on. So line 222 through 234 define the onResume method that registers listeners to be called when new data from sensors is available. For example, in line 225 through 227, it sets up a listener for the accelerometer. Line 227 sets a parameter to get the data as fast as possible. In lines 72 through 79, colors are set for different graph lines. Lines 81 through 83 set parameters for drawing. Lines 86 through 103 define an override of the onSizeChanged method. And this is called during a layout when the size of this view has changed and we can make adjustments to the height and width of the display. Lines 105 through 171 define an override of the onDraw method, which is used to draw plotted lines for sensor values. Lines 173 through 201 define an override of the onSensorChanged method, which is called when sensor values have changed. Lines 179 through 181 is an example of retrieving the three orientation values from the accelerometer sensor event, providing the X, Y, and Z axis values. The type here says orientation, but remember down below in line 226, we registered a listener for the accelerometer, and those are the values that we're getting. Line 203 defines a method for onAccuracyChanged that isn't being used and has a blank body. And it's here that you can include code to react to a change in accuracy if you wanted to. Lines 212 through 220 define the onCreate method. Line 217 gets a sensor manager using the getSystemService method. Line 218 creates a GraphView object. 219 sets the graph view as our display. 222 through 234 define the onResume method that we've already looked at that sets up the listeners for sensor value changes. And 236 through 240 define the onStop method that unregisters the sensor event listeners. That's our lesson on sensors. Essentially, it's pretty simple. You set up listeners for changes in sensor values, and then in the methods that you've set up to respond to those listeners, you use values from the sensors to take actions in your app. In this and the next lesson, you'll learn how to determine physical address locations based on geocode latitude and longitude information. This page on the developer's website provides a lot of good information and references for determining and using geographic locations. In this and the next lesson, we'll use a sample app to examine the code needed to retrieve location information. We'll use the Location Activity sample app included in the Working Files Samples workspace. You can use it from the working files or download it yourself. To download it, in the training group on the developer's website, go to the Making Your App Location Aware section. Off to the right, you'll find a button to download the sample app. And watch for these demos on the developer's website. Sometimes they're apps you won't find using the wizard capability we studied in our lesson on using wizards and templates. So click the Download button, and you should see the app download onto your computer. And then you save the file to a folder on your computer. I put mine here in this location-aware example folder. There's the zip file. And then you'd unzip the file. I put it here in this same folder. You see it there. Then go to Eclipse and use the File, New, Other, Android sample project from existing code, click Next, and then you'd find the file on your computer wherever you've put it. And you see here, I've pulled it up on my computer. You'd click OK. Select the project. You'd click Copy it into Workspace. And I already have it on my computer, so it's not letting me take the next step, but you'd then click Finish, and it will load it into your workspace as I have it here. So now from the app source folder, let's open the main activity, location activity. And because the app requires network services not available on the emulator, I'm going to show you a screenshot of the app from my phone. So in DDMS, select my phone, click the screenshot button, and there we have it. So the app has two buttons, one to select using the fine-grained provider only, and the other to use both providers, fine-grained network provider and GPS. So that it pulls up the latitude and longitude coordinates, and then we look up the street address and put both on the display. So back to the Java code. Now, this demo includes a lot of useful details on how to use Android location capabilities. Consequently, there's quite a bit of code, and this is one reason we have 2 lessons to cover this topic. So let's get started. Line 47 declares our location activity as an extension of the fragment activity class, and you can learn more about fragments in that lesson of the course. Lines 48 through 67 define variables we'll be using below. 75 through 115 define the onCreate method. Line 78 uses the setContentView method to initialize the display using the main layout. So let's take a look at that quickly. So in the Layout folder, click the main XML file. And lines 17 through 20 define a linear layout. 21 through 23 define another linear layout within the first. 24 through 38 define the provider buttons. Line 30 sets the onClick method for the find provider as use find provider in our Java file. Line 38 sets the onClick method for using both course and find providers as use course find providers in our Java file. And lines 40 through 48 define fields for the latitude and longitude information, and 49 through 57 define fields for the physical address information. Now back in our Java source code, lines 81 through 87 restore the app state after the user has rotated their device. 88 defines a text view variable for the latitude and longitude layout field, and 89 defines a text view variable for the physical address layout field. 91 and 94 define button variables for our 2 buttons. 97 sets the geocoder availability to true. Lines 101 through 112 define a handler for updating text fields in the user interface. And a handler allows you to send and process message and runnable objects associated with a thread's message queue. Line 114 sets up a location manager object that provides access to the system location services. And these services allow applications to obtain periodic updates of the device's geographical location. Lines 118 through 123 define the onSave instance state method to restore the user interface states after device rotation. 125 through 129 define the onResume method, which executes the setup method, which is defined below and we'll examine later. Lines 131 through 141 define the onStart method, and here we check if the GPS setting is currently enabled on the device. Lines 153 through 155 define a method to launch the settings display, and it doesn't look like this is being used in the app. And lines 159 through 163 define the onStop method that removes the listener from the location manager. And that's the end of the Part 1 lesson on determining locations. Well, let's move on to Part 2 in the next lesson. This is the second of our 2 lessons on determining locations. And make sure you have the location activity Java source code open in Eclipse as we did in the previous lesson. Lines 167 through 202 define our setup method that establishes find and/or course location providers depending on which button is pressed. 168 sets up a location variable for the GPS location. A location variable can consist of a latitude, longitude, timestamp, and other information such as bearing, altitude, and velocity. 169 sets up a location variable for the network location. 170 removes all location updates for the location manager. 171 and 172 initialize the latitude and longitude and address displays and set them as unknown. 174 through 181 define code for the Use Find option. 175 and 176 set up background colors for our buttons. And these are working fine on my phone, but are fuzzy on the emulator, and we won't worry about that. 178 and 179 request a GPS update from the provider using a method below we'll examine shortly. The first parameter in line 179 specifies the provider, and the second parameter specifies the string to be displayed if the provider doesn't exist on the device. Line 181 updates the location on the display based on the new location provided. 182 through 200 define code for the Use Both Find and Course option. 184 through 188 are just like lines 175 through 179 up above. Line 189 and 190 request a network update from the provider. It's just like lines 187 and 188, except for using a network instead of a GPS provider. Lines 194 through 200 use the best result to update the display. Lines 215 through 224 define the request update from provider method that we used above. 217 tests to see if the provider is enabled. 218 and 219, if the provider is enabled, use two location manager methods to get a location. Line 218 requests a location update, and line 219 retrieves the last known location. 221 toasts an error message if no provider is enabled. 223 returns the location. 227 through 231 define a method to set variables to indicate using the find provider. 234 through 237 define a method to set variables to indicate using the find and course providers. 240 through 244 define a reverse geocoding method that translates latitude and longitude into a street address. 243 uses the reverse geocoding task class below to avoid tying up the UI thread, and we'll look at that class in a moment. 246 through 254 send an update to a handler, which then updates the UI with the new location. 257 through 277 define the location listener object. 259 through 264 define the onLocationChanged method that updates the UI with the new information. 266 through 276 define three empty method overrides that we're not using in the app. 288 through 328 define the getBetterLocation method that determines whether a location reading is better than the current location fix. 289 through 292 return the new location if no current location fix exists. 295 through 298 check whether the new location fix is newer or older. 302 through 307 use the new location if the current fix is more than 2 minutes old. 310 through 313 use the getAccuracy method to check whether the new location fix is more or less accurate than the current fix. 316 and 317 check if the old and new location are from the same provider. 320 through 327 determine location quality using a combination of timeliness and accuracy. 331 through 335 check whether two providers are the same. 340 through 373 define the reverse geocoding task class by extending async task. And you can review the lesson on threads and async tasks for additional information on running tasks in the background. 350 defines a geocoder variable and object. And geocoding is the process of transforming a street address or other description of a location into a latitude and longitude coordinates. Reverse geocoding is the process of transforming a latitude and longitude coordinate into a physical address. The amount of detail in a reverse geocoded location description can vary. For example, one might contain the full street address of the closest building, while another might contain only a city name and postal code. 352 and 353 define variables for a location and a list of addresses. 355 obtains a list of addresses using the getFromLocation method of the geocoder. 361 checks to see if any addresses were returned. 362 retrieves the first address from the list. 364 through 367 format an address string. And 369 updates the address field in our user interface. That's part 2 of our lesson on determining locations. As you saw, there are a lot of details to attend to, and you should be able to use this demo as a good base for dealing with these details and getting location information in your apps.